Hello again, everyone. This time around, we are going to be doing a different type of circuit. We are going to be doing a parallel circuit. Before we did a series circuit, now we are going to do a parallel circuit. Now, what are some of the fundamentals of a parallel circuit? Well, we know that voltage across each of the devices is the same. However, the current is different. And what do I mean by that? Let's draw a circuit. Okay, we have our source voltage, 10 volts. We have R1, like we had before, R2, R3. The value for R1, we're going to call it 3 ohms. Value for R2 is going to be 2 ohms. Value for R3 is going to be 4 ohms. Okay? I said the voltage is the same, right? What that means is that if I were to take a voltmeter, let's put the voltmeter here, and these are the leads for the voltmeter, and I were to connect one at this node and one at this node, it will read 10 volts because they share the same node as your battery. See that? So it will read 10 volts. And the same applies for this. This will also be 10 volts and this will also be 10 volts. However, the amount of current that flows through each resistor will be different. Unless, of course, the values of your resistors are the same. Okay? Then the current is just simply going to be divided up evenly. However, that's not always the case. All right? So let's go ahead now, as we did before, and find RT for this circuit. Now, there are two ways to find RT, which is the total resistance in a parallel circuit. First method. First method says that RT is equal to R1 times R2 over R1 plus R2. That's one method. The next one says that RT is equal to 1 over R1 plus 1 over R2. These are your two choices of formulas that you have, that you can use. They both give you the same answer. It's just a matter of which one you are comfortable with. Okay? So we are going to use both of them for our case, just for me to show you that it's going to work out to be the same thing. To begin with, we'll find a parallel combination for these two resistors, R1 and R2. So R parallel, that's why I'm putting RP, is equal to R1 times R2 over R1 plus R2. And that gives us a total of R1 is 3 ohms multiplied by R2, which is 2 ohms, over 3 ohms plus 2 ohms. 3 2s are 6. 3 and 2 is 5. And if we were to put this in our calculators, we will find that we get an answer of 1.33 ohms. Now, is this RT? No. This is our parallel combination for these two. So let me go ahead now and redraw this original circuit. Okay? And we're going to call this RP. Note I didn't call it R1 or R2, I call it RP. This still remains R3 because we have not included this one as yet. All right? This still remains 10 volts as we had before. Now, what's going to be the parallel combination here for these two resistors? Which is going to be our RT, our total resistance? it is simply going to be RT is equal to RP multiplied by R3 over RP plus R3. That's going to be 1.33 multiplied by 4 ohms over 1.33 plus 4 ohms. And if you were to put this into your calculators, you will get the answer of oops, sorry, just a little glitch here. If you were to put that into your calculator, you'll get the answer of 0.923 ohms. Don't forget your units, very important. Okay? So our total resistance for this circuit is going to be 0.923 ohms. Okay? Well, now that we have known that, I could go ahead and redraw the circuit once again. 10 volts. Notice I did not call this resistor R1 or R2 or even RP. I call it RT. And its value is going to be 0.923 ohms. Okay? Good. Let's just quickly remove this. So we know our RT using one method. Let's go ahead now and use the other method, because remember I told you there were two methods. The second method simply says that RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. That equals 1 over 3 ohms plus 1 over 2 ohms plus 1 over 4 ohms. That's going to be equal to 1 over 3 is if you put it in your calculators, 0.33. 1 over 2 is 0.5, well that's easy. And 1 over 4 is 0.25. Okay? If you were to go ahead now and add these up, you will get 1.083. So it's going to be 1 over 1.083. Now, where many people make the error is that they simply add these up and forget about this one. Please don't make that mistake. If you were to put this now into your calculators, you will find that you will get 0.923, which is the answer we got before. Okay? So you see that it doesn't matter which one of them you use, your answer will be the same. So it's just a matter of your choice. All right? So we know our RT. RT equals 0.923 ohms. Okay? All right, let's go ahead now, and we are going to find how much current is flowing through each of these resistors. Remember the Ohm's law that I showed you before? V over I times R. So how much current is going through R1? So IR1 is going to be equal to VT, which is your total voltage, which is, for our case, is 10 volts, right? Over R1. Notice I did not put RP, I did not put RT, I put R1, because that's what we want to find out for right now. And that's going to be equal to 10 volts over 3 ohms. And if you quickly put this into your calculators, we get an answer of 3.33. So IR1 is 3.33 amps. Okay? So we're going to put IR1 is equal to 3.33 amps. If we were to go ahead and calculate IR2, how much current is flowing through R2 resistor. It's simply going to be Vt again over R2, which is 2 ohms. So is equal to 10 over 2, which is equal to 5 amps. So the amount of current that is flowing through this resistor R2 is 5 amps. We'll quickly record this here. Okay, and we will continue. Find out how much current is flowing through R3. So IR3 is going to equal to Vt, which is 10 volts, over R3, which is 4 ohms. And if you put that in your calculator, you're going to get 2.5 amps. Okay? So let me just quickly record this. IR3 is equal to 2.5 amps. Now, when I was doing the series circuit, I double-checked to make sure that my current values were correct by simply adding them up and see if I had gotten back the source voltage. Let's find the total current in this circuit. Now, to do that, we're going to have to come back to this sub-circuit here. If I know my voltage, okay, and I know my resistance, using Ohm's law, which is V over I times R, I could simply find the current in this circuit. It will be 10 volts over 0.923. And if you put that in your calculator real quick, 10 divided by 0.923, you get 10.83. 10.83. Okay? Go ahead now, and you can do this on your own. Add these up and see if you get back this answer. If you get it back, then you know that, yes, you are correct with finding these values. Okay, let's continue. Other things I would like to know about this circuit. Well, I found my IT, which is 10.83 amps. Okay? And it's as simple as that. So your voltage, current, divided up in this parallel circuit is as simple as that. Remember to study hard.